Hi, welcome to yet another lecture on the NPTEL course on Haskell. In this lecture, we will look at more on input output, some more advanced features. We will not be covering the entirety of the Haskell material on input output. This is just the previous lecture and this lecture, but this is the most basic stuff that will help us write input output in as part of our own programs. Okay, we will see we are introducing input output now roughly in the middle of the course, so that in the remainder of the course, whatever we program, we can test out lots of things in an interactive manner using these input output ideas that we have learnt in these lectures. Okay, with that introduction, let me get into the lectures. Let me get into the slides. The first few slides will be a recap of the earlier material on input output that we have seen. So recall that Haskell type system allows us to combine pure functions and actions in a safe manner by actually putting a tag called IO for all the output types of input output actions. If any component of a larger program has some IO, then the larger program also should be tagged IO, right? So this way, you know when you look at a program that there may be side effects. Okay, whereas if a program doesn't have IO in either the input or output types, in given the material we have seen so far, there won't be any side effects. Okay, so if there are no side effects, then anytime you call the same function with the same arguments, you will get the same value. Okay, whereas the same is not true with programs with side effects, because these programs might take an integer as input and produce an integer as output, but meanwhile they also read some other memory locations, they read user input perhaps, and each time they do that, they might get actually different, you might actually get different behavior. Maybe they read, maybe they modify a few global memory variables and then read from a few other global memory variables, and if the same function is called twice, by the time the second call is made, the global memory might have changed. Okay, so these are all problems that you have to worry about in a language like C or Java or Python or some of these languages. Of course, this is the way in which you get computation done. That is the model in those languages. But in Haskell, you don't need to worry about these things. If a function does not have IO in its output type, then it means that it's a, you can call it whenever you want, right? And it is guaranteed to produce the same value, right? Because it's just like a mathematical function. Okay, and this particular feature that I mentioned just now is called referential transparency. Okay, so that's a big name. But what it means is that it doesn't matter when you refer to that expression, it will always have the same value. Okay, so it also means that you can perform some optimizations. If you have computed an expression once, maybe you can replace that expression by the value. So referential transparency really means that whether you refer to it via the expression or by the final value, it doesn't matter. Okay. Anyway, so those are all some theoretical concepts which are not really necessary to program nicely with Haskell. Okay, let's move on. So there is no mechanism to execute an action inside a pure function, which is what I have been mentioning so far. But pure functions can be used as subroutines inside actions, and we saw examples of that. IO is performed by an action only if it is executed from within another action, and all action begins at main. Okay, or if you are in GHCI, all action begins at print, which GHCI implicitly does when you write an expression in GHCI. Right? It says you write an expression factorial 10. What GHCI does is say that, oh, print factorial 10 is what it internally says, and because of the print, some that is the input output action where everything where all action begins. Okay, fine. And we saw examples of repetitions of programs, and importantly we saw this return, right? Return or pure are ways of a value has type A, you just want to promote the type to IOA, okay, and return achieves that. Okay, so you could say, for instance, get an input line from the user, print 10 times that input line. Printing 0 times is just the same as saying return unit. Printing n times is the same as printing once and then printing n minus 1 time. So this is just basic recursion inside a do block. Again, that's one of the most basic ways of ensuring repetitive actions in Haskell. Okay, good. So then we saw this, that you can, for instance, say that implement get line in terms of get character. So you could, so you read the first character. If it is the new line, you return the empty string. Remember again that return is just promoting empty string to type IO string. Else you recursively call getLine, which will get the remaining characters, and then you tag C in front of C's. So you put C in front of C's and you promote it to IO string. Okay, and that's this return. Okay, we can actually program this and see how this works. Let me switch to VS Code now. Okay, so we have this hw.hs program. We'll just abuse it and tack on various things to that same program. And because getLine is a built-in Haskell function, we have to say we cannot re-implement getLine. Let's call this function myGetLine. Okay. Okay, so let's recall that string is just another name for list of characters. So you are really getting a list of characters now. myGetLine equals do get a first character, name it C, check if C is the new line character. If so, return the empty string, not return the empty string, promote the empty string, and this stops the computation. You see, the if branch stops there, only the else branch goes on to do more work. And I said I'll use pure instead of return, just to avoid confusion between return and this thing, pure. Okay, that's it. And let's test if this works. Okay, so there is some parse error. It says, yeah, there is an error because I used backticks instead of single apostrophe. Okay, so let me go and fix it. Okay, now this will work. Okay, now this compiles, and I can actually say myGetLine my get line, that's it. Okay, so now it will ask me to print various input various characters. The moment I press the enter key, it will stop, or hopefully so. Let's see. Yeah, see, and so why is this being displayed even though we didn't ask it to print out anything in the program? The program doesn't really have any put string line or anything, right? It's printing out because GHCI itself automatically, no matter what expression you give it, it has a built-in print. It will say print this. That is why you see extra quotes here. Okay, so the extra quotes is to say that this is a string that has been extracted from this. Okay, suppose you did put string line, there wouldn't be these quotes around them. Okay, let's test that. So let's go to hw.hs, let's say this, and after doing all this, let us say main 6, let's say, my get line, I should give it a name, I will call it ln, and then I will say put string line ln. Now if I call main 6, right, let me just reload. Now I will say main 6, and now once again I have to give it an input. Let me just print all this. Now it will print out the same thing but without the quotes. Let's check that. Yes, do you see? That's because put string line actually puts the thing. The earlier thing came with the quotes because GHCA automatically adds a print for every expression that you type to it. So my get line will have a return value and GHCA will print the return value. Okay. And you can also test that here when I go to the hw.hs, and instead of putting put string line, let's say I put a put string line ln first and then a print ln next. Now you will see the distinction between these two. Print ln will take any showable object and print it as it is. If it's a string, it will print it with the quotes, right? Because strings are supposed to come with the quotes, right? So see, once it prints without the quotes, print will print it with the quotes, right? Put string line will display it without the quotes. Okay, so that's one thing. Let me get back to the slides. Yeah, here this is another example that we saw at the end of last class, how you can actually take an input output action as a parameter here and do something with it. You are repeating it n times. Okay, so you could do that. And here is how you would read and print 10 lines. Yeah, so you 10 times you ask the user for input and immediately print it out. Here is another function. So far we have seen put string line, print, put character, get character, get line. This is to read a character, read a line which is a string, it will read it as a string. This will display a character, display a string, print will display any showable value, what we would want is an equivalent of print, and that is called read line, which will read any readable value. Okay, so note that the type class read is the sort of the opposite of the type, dual of the type class show. These are all things that the user can enter on the keyboard and they can be unambiguously parsed as a correct value. Okay. So read line, the type is read line is of type read a arrow IOA, and when it comes to read line, we will see that the way you do read line is to say read line. So you will say n is right, you need to specify a type, read line colon. Why? Because if you just say read line, the Haskell won't know what you want to read it as. Okay, the user is producing an input, you need to tell, oh, I need to read this as an integer. So, but sometimes from the context, if it can figure out the type, that is fine. Then you don't need to say read line IO int. So, for instance, if I want to say n is the name that I give to the value that is read, and then you say put string line factorial n, and if factorial has been given type int arrow integer, then this read line is automatically of type IO integer, and this n will be of type integer. Okay, that's all inferred automatically. You don't need to supply. But when there are situations when you cannot infer, in which case you have to actually explicitly say the type. Okay, so that's the only thing. And all basic types like int, bool, char, etc. are all instances of read. Basic type constructors also preserve readability. For instance, int is a member of type class read. Therefore, the type list int is also a member of the type class read. Okay, you can also read lists of integers. You can also read tuples of integers, etc. So yeah, list of int, the triple int, bool, char, etc. are all instances of read. Of course, functions of type int arrow int are not readable. How do you even give a function as input, right? And syntax to read an integer is something like this. Input is input left arrow, and this says bind the result of read line to the name input, and the result is integer. So therefore, read line itself is of type IO integer. Okay, and you are just specifying that type. Okay, so here is an example: read non-negative integers and print the corresponding factorial. Okay, so we will now program this in VS Code, and we will check what kind of results are produced. Okay, so let me just go and program this. So now we need to first write a factorial program. Let's write a naive factorial program. Let's assume that there are only non-negative integers. So factorial is a function of type integer or integer. Factorial 0 equals 1. Factorial n is n times factorial n minus 1. Okay, so that's done. Then in main, whatever number it is, main 7, what I want to do is the following. And I want to read only non-negative integers. So the moment it becomes negative, I want to stop. So if n is less than 0, then maybe you can print a goodbye message and exit. And exiting is nothing but saying return unit, because actually you don't need to do anything. You're just printing the exiting mail and that's it, right? Because the if blocks, this is the last action in the if block, in the then block, in the then branch. So that's it. It stops. Else do, and in fact you don't even need a do here because it's just one single action. Else you do and then you say put string line the value of you have to do a dollar here because it's a complex expression. You have plus plus that you are using in the argument of put string line. So the value of factorial n is equal to fac n. So you have printed this factorial. What do you want to do? You want to repeat this again. So you want the user to keep on entering inputs, and the only way to exit is to say -0. Okay, that's it. So you recursively call main7 and that's fine. So let's see how it works. Let's reload the program. It compiles thankfully. Okay, main7. Okay, so let me enter 20. Is that even correct? That must be correct because let's enter 10. Yeah, let's enter 5. 120. Yeah. So, and then at some point in time I get bored of all this. I enter 0. It gives me value 1. If I am bored, I will say -20. Then it will exit. Okay. So that's a nice program. See, we are just doing more and more. Earlier we had a way to repeat an action a fixed number of times, right? And the fixed number of times is part of the program itself. Now we are repeating some action, and whether we continue to repeat the same action or whether we stop is based on the user input. Okay. The moment the user gives a negative input, you stop. Okay. So this is another this is just another illustration of how you would repetitively do tasks. This is also a common kind of simple input output program that you would write in other languages. You can do the same thing in Haskell also. Yes. So let me get back to the slides. Yeah, I am doing the same thing here in the slides, except I am adding one extra twist, okay, which I will go back to GHCA to illustrate, to VS Code to illustrate. The point is, I said put string line, enter a number. So it said enter an integer or whatever, and then in the next line it expected the input. But normally you would want to expect the input on the same line, right? But if you do that, you will not always get the desired effect, and that is because input output follows what most systems follow, something called buffered input output. So they will not immediately print everything out to the screen unless there is some trigger to it. Okay, so the moment you say put string line, enter a number, it won't. If you say put string line, enter a number, it will immediately print it on screen, because the trigger that forces it to display something on screen is the new line character. The moment it encounters a new line character, it says, oh, somebody is asking us to show something on screen and there is a new line character, which means this is one whole line. I'll print everything, everything up to this new line character I'll show on the screen. Okay, that's a trigger for the system to actually print something on the screen. The system won't print character by character. It will wait for a while, accumulate enough characters and then only print, unless it is triggered, and one of the triggers is the new line character. So put string line works properly, but if you say put string, it might not always immediately print it, right? Because there is no trigger. It will print it only after you the user enters the input corresponding to that n left arrow read ln. Okay, it will wait till that read ln thing, and then the user is pressing an enter. Remember that whenever the user inputs some input to the computer also does a echoing on the screen. Okay, the computer echoes whatever input the user enters on the keyboard onto the screen. As part of that, there is a new line. At that point, it will decide, oh, so the user has entered so much input which has to be echoed onto the screen, and there is a new line also. So let me flush all the output. So at that point, it will whatever has been stored in the buffer of the output buffer, it will just put that. So you will get some things in some random order when you do this. Therefore, you have to explicitly do some system thing called hflush standard out. Standard out is the name of the standard output device, as it's called in Unix, the place where all output should go, okay, and this is typically the screen. Hflush is just an it is just a kind of an instruction to the operating system in some sense, or to the underlying ecosystem. Okay, so hflush is not part of some problem solving in Haskell or whatever, but it is part of some kind of management that you need to do when you are working in a computer system. Okay, so when it comes to IO, there are till now we didn't introduce too many mysterious special commands or whatever in Haskell, but when it comes to IO, you need to remember just a few things. One of the a few things from system.io. Okay, system.io is a thing that I'll import now, and it has this reference to this standard out, and it has a function called hflush, which will have the correct kind of behavior. And to illustrate this, I shall go back to VS Code and first change that main7 to main and compile it using GHC, and we will see what happens, and then we will fix it. Okay, let me go to VS Code now. Here, instead of running it in GHCI, I will first change this main7 to main. I hope there is no other main earlier. There is a main earlier. I will call it main0. And this I will call main. And curiously, this works fine in GHCI, but it will not work fine in the command line. And let me illustrate this. Let's compile the function. And just to tell you that main is nothing, just like you can invoke other functions from GHCA, you can also invoke main. There's nothing sacrosanct about main. You say 20, it prints out something, you say 21, it prints out something else, and then you say -3, it stops. Okay, so it is the same function. Okay, and now it is working fine. That's because it still has put string line. Let's change the put string line to put string. Okay, and let's see what happens. Typically, you will expect an input on the same line. Okay, we have done this change. Let me go back to GSCA. Let's reload this and let's clear screen, and let's do main again. Yeah, it says enter an integer and it's waits for you to enter. Maybe I didn't. Yeah, sure. So -1. Okay. So typically you would give another space. So let's do that properly. Okay, this is the way it should be done. Okay, it says enter an integer 22, enter an integer -1. We are exiting. Okay, this is fine. But let's try to compile this in the command line, and let's see what happens when you run it from the terminal. So ghchw. Okay, so it's compiling. Let's give it a few minutes. Yeah, now it will produce it is producing hw.exe. Okay, this is done. So let's try to execute it. See, now you see nothing. Okay, maybe you enter something now. Anyway, in Windows it takes a while for the program to execute. Okay. But see, now you say 20 and then it says enter an integer. You see, I entered the input first and then it is printing out that enter an integer because of buffered input output. Okay. So to fix this, let me exit this program and let's go here, and I should import system.io. Okay, so I am doing this. Let me come down, and right after saying this, I shall also say hflush standard out. The H in hflush stands for handle. Okay, standard out, standard in, etc., etc., are all called handles. This comes from way back from Unix. Okay, and handles are nothing but just some pointers pointing to some input buffers, output buffers, etc. Hflush standard out means buffer the flush the buffer pointed to by the handle standard out. Okay, and anyway, this is just a kind of a system thing. Okay, but it's useful to know. Let me compile. Let me save this program and come to come to the shell and compile it. Okay, it's compiled. Let me why does it take so much time? Anyway, let's wait. Okay, it says enter an integer. Now you say 20, prints out something. It again asks you to enter an integer. Now it's fine, right, on the command line. So this is just a minor detail, but it's a useful thing to remember. Hflush standard out. Okay, and minus 22. Now this exits. Okay, great. So okay, so we are learning more and more. Let's go back to the slides. We have seen this. Here is another example. I want to read non-negative integers, one on each line, and collect them together as a list, and I want to print the list at the end. Okay, so non-negative integers. So if I encounter a negative number, I will stop. Okay, so let's look at this read int list function. Okay, so I will do read line io int and call it x. I mean bind the name to x. If x is less than 0, I return the empty list. Okay, return here again means it's just promotion. Okay, I could have written pure empty list. Okay, fine. Else you read the rest of the list and then you put x in front of read the rest of the lines, form a list, put x in front of that. Right, and because recursively whatever list you produce is of type IO list int, therefore you have to actually extract the value and bind. Xs is of type list int, but you have to extract the value from the recursive call and bind it to xs. Okay, because the recursive call itself is of type IO list int. Okay, so this is something that you can do. And finally, what you say is, oh, you make a call to read list int. It will produce a list, call it xs, and then print xs. Okay, so this is the kind of thing that you can do. But there is something slightly uneasy here. Every time I am saying, oh, read non-negative numbers, and moment you encounter a negative number, you say exit. This is not the most satisfactory. What if you want to signal the end of input by some other means? Okay, there are various other ways in which things might end. Basically, maybe it is because you have run out of data. Okay, maybe you are reading from a file and you have run out of all lines in the file. You are reading one number on each line in a file, and the file ends, so therefore your input also has ended. Okay, or you are asking a user to keep making entries. At some point of time, the user presses some control D or some such, which signifies that one has to exit. Okay, there is no more input. How do you do that? Okay, and for that you have to use something called is-eof, which is again part of system.io. So far we have learned three concepts from system.io: hflush, standard out, and is-eof. Okay, and is-eof is of type IO bool, which is why here exit condition is a name that you bind the result of is-eof to the name exit condition, and exit condition can be used as a Boolean condition and if then else, right? That's what you are able to do, right? So what you are saying is, you first check if exit condition has been reached by making the call to is-eof. It will return, it is an IO action because it is to interact with some file or user or whatever, and then it will return a Boolean value saying true or false. True means end of file has been reached, false means end of file has not been reached. If end of file has been reached, then once again you do promote the empty list as a list of integers, promote the empty list to type IO list int, else you read an integer and you read the rest of the integers and you promote x colon xs as a list of integers. Okay, so let's actually program this. Let me go to hw.hs, and in my imports I will also add is-eof. Okay, and I will come here, and as part of my main I shall say not if n less than integer, but rather as soon as I enter I will say, okay, so this is a new main, so I will call this main 7, and go to main 8 in the subsequent thing, or just main, let's say. And what I want to do here is, the very first thing that I will do is to check if exit condition has been reached. Else you read a line of input and interpret it as an integer. You read the rest of the lines. Okay, so now I shouldn't be calling this main, I should be calling this read int list. Okay, and then I will say, oh, xs is nothing but read the rest of the lines into a list. Let me just call it read ints. Okay, and let me also provide the type. Read ints is of type IO list int. Okay, okay, great. So let's see if this compiles. But we have to write a main, and all that the main does is to read ints and print out the list. Okay, great. So this is what we have. Let's save this. Let's go to the command line and let's say GHC HW. Okay. Yeah, I cannot say if is EOF. I have to say if exit condition, right? Because EOF is not a boolean; it's of type IO bool. Okay, so let's go back and do this. Okay, yes, it has compiled, thankfully. Now I can say okay, now I just need to, there is no prompt or anything, I just need to keep entering numbers 2, 3, I don't know why. Okay, it's taking a while to, yeah, I have entered some numbers 2, 3, 5, 8, and at some point of time I will say control D, that doesn't work, maybe control C will work. Yeah, control C works, control C to stop your input, and you see now the moment you said control C, it recognizes that there is no more input and it's printing out the list 2358. And the same thing will also work when you are reading from a file. We haven't yet introduced how you will read from a file, but I can just show you there is no VI. I need I have an editor right here, right? I am using an editor here. So let me create a new file called hw.in and I shall, yeah, 2358, and let's say it stops from, there are only four lines of input to read. Let's see what happens when I run hw.exe on this. There is no need to recompile or do anything. I will just do the same hw.exe, except I will say read inputs from hw.in. Yeah, and that is done by using less than hw.in in the PowerShell or in the terminal if you are using Mac OS or Unix. Okay, so I need to figure out how to use input-output redirection in Windows. I'm sorry about it. Once I figure out, then you can do this. Okay, in the next class, I will tell you how to do this. I'm sorry about not knowing this now. Okay, okay. Yeah, but you see the point about this is EOF, right? Because I entered a few numbers and then I said control C and then it stopped input and you got 2358, the output that was printed, because you cannot always expect the user to enter some negative numbers or whatever, because what if you want to permit negative numbers also as legitimate inputs, right? So you want this feature. Okay, so here we have read one line after another in sequence and a bunch of numbers, one number on each line, and then we compose them all together as a list. Okay, that's a very standard pattern.